Yeah, good morning, everybody. Thanks very much for joining me this morning. We're here looking at lesson 5, one of the larger challenges in the course. At least takes a little bit of work to navigate through this lesson. And we're going to take a look at all the different assignments that you're being asked to do today. Or sorry, for next week. And in particular, we're going to look at the watershed assignment and the micro watershed to be really specific. So I will probably just touch on the rest of the assignment, and we'll show you some examples of the micro watershed. In my experience, it can be a tough concept for people to grapple with, and it takes a little bit of practice. Admittedly, myself, the same thing. When I first started looking at micro watersheds, it does take a little bit of practice to get the hang of it and understand how water flows through the landscape. So maybe what we'll do here is I will share my screen. There we go. All right. And we'll take a look at lesson 5. So as you can see, we've got 3 different parts of the assignment. I'll just get my little spotlight tool. There we go. So we have a water survey, which is pretty straightforward. We're just asking, where does your potable water source come from and your wastewater go? And that can be interesting. Depending on your location, sometimes it's dramatically similar. The watershed map we're going to look at, and that's, again, a big part of the assignment. And in a lot of ways, it's a really key part of understanding getting the most out of a permaculture design is how water moves, not only through your project site, but on other sites that might influence yours. And then we're going to look at the water flow analysis. So that, again, that gets quite a few points allocated to it. And it's not so tricky. It's more just really documenting the areas, the rainfall events, and taking some of the data that you first collected way back in the early part of the course when we're looking at annual average precipitation, as well as 24-hour rain event records for your area or for your project site. And some of you may not have that, but if you do, it will certainly be an added little piece of information. And in a lot of ways, when we're designing water systems, we want to be able to design them in such a way that they'll be able to cope with maximum flow rates coming into them. So an example of that would be just gutter systems on houses. They're often designed for, engineers have different rainfall designations for different areas. I know where I live, I believe it's a 35 millimeter rain event over 1 hour. That's what they design the systems to. So converted that into inches. Let me see. I'll have to do that here for you. I grew up with both standard and okay, so that's almost 1.4 inches in a 1 hour period, which is a lot. So what we want to do though is figure out, let's say you're building a rain garden or a swale system, or you're capturing rainwater. All of these bits of data are going to be really helpful to determine. For instance, let's say you have a rainwater catchment system where you're collecting rainwater for reuse in a cistern. You really have to have a handle on how much water comes in during the year, and then what your usage is to determine whether your cistern's large enough. But let's not get too buried into that right now. We will just take a quick peek at the assignments here. So again, the water survey, pretty straightforward. The watershed map is what I really want to focus on, but we'll just quickly go over that here. So we want the macro watershed and the micro watershed, the macro being large, and that's pretty easy to find. If you just put in, an easy Google search will get you that. So those are quite easy to locate, at least in North America. And if we're looking at the micro watershed, that is a little bit trickier. So that's where we need contour information about not only our project site, but neighboring sites around ours. So we're going to, again, spend some time on that. And some of the elements we want to include, there's a practice sheet within the template file, and we'll take a look at that. And most of the time, people do that really well. It gets harder when we're applying it to our own project sites. So again, we want to pinpoint whenever you include a map, so a map of your macro watershed basin, you want to include where your site sits within that. And then we want to get into the micro watershed boundary. So that's really looking at lands above your project site that influence or could influence your site. They may or may not, but they could. Another thing we're going to look at is placing the basin around that. So we have a boundary, and then the basin is within that. And then how do those water flow patterns flow within the micro watershed? So that seems pretty straightforward. The third part is the water flow analysis, where we're analyzing some of the information. We're going to have a map. So you're going to take your base plan and you're going to create a new layer, so to speak. You're going to use it as a template and write over that, however you're doing that. And we want to see where water comes into the site, where it leaves the site. We want some data on your impervious surfaces. So that'd be the roof areas, where you might be able to collect gray water, or sorry, where you might be able to send a gray water system out into your landscape. The other thing too, which I'm sure is on here, yes, other impervious surfaces. So driveways, walkways, patios, those are all impermeable, even a gravel driveway. So you want to make note of that and the size of it. Direction of the water flow, whether you have any ponds or water features. The contour lines are absolutely essential for this exercise. So I apologize. All the red alder are flowering in my area, and so my throat is doesn't like that. Let's see, any well locations or details on that. So if you do have a well, a drilled well or a shallow well, it's really helpful to know some details, and some of those details are the actual flow rate in gallons per minute and the depth. You can get into more detail like the static. So for instance, our drilled well is 225 feet deep. We have 8 to 10 gallons a minute, and we usually have about 100 feet of water in our well, even during the summer when it's very dry. So we're super lucky that way. I have a friend who lives not too far from here, from we are, and he only has 2 gallons a minute. And right next door to where he lives, they have 500 gallons a minute. So it can change dramatically in a short distance, and depending on where you're tapping into the groundwater, if that is your water source, which is often the case with larger properties. So that's the map. Okay, a big part of this assignment. And then we have a chart. So the charts that we're going to look at are all about precipitation. and how they relate to your roof areas and impermeable surfaces. And then when we get into roof materials and the driveway, what are those coefficient factors? So if we have a rainfall event on your roof, how much of that water is actually going to end up in a downspout? And most people would think, well, all of it, but that's not the case. Asphalt shingle roofs are typically, you'll get like a 0.8 coefficient factor or 0.85. So you lose 15 to 20% of your total rainfall. And that's through absorption, and splash and other factors. Probably one of the best surfaces is metal, and that's more up in the 0.9, 0.95 region. We just switched our roofing last year, so we've gone with metal, and we're very much appreciative of the high quality water that we're getting from it. And not only that, we are seeing much more water coming off our roof into collection. We want to know the square footage of these areas and your impermeable surfaces. And then you can take that and look at the total rainfall on your project site in a year and the total volume in a 24-hour rain event. So when we get, even on a small urban lot, the staggering amount of water that falls in a calendar year in the Pacific Northwest. Obviously, if you're going into drier regions, Southern Oregon and California, that number is going to be lower, but it's still quite significant. So with all that, you're going to know your yearly runoff volume, how much water falls on your property. And for most of us, well, not myself, but say for most urban sites, they're really set up to um, take water off the roof, off any of the land, and into the storm system as quickly as possible. So we tend to over drain our sites through the winter months, and then we pump it in during the summer. So this is one of the reasons I feel the water layer is one of the most important in permaculture design is how can we manage that so we can hold some of that water on our project sites. So we've been doing this for years on our own site here. We've been collecting rainwater for quite a long time, well over a decade. We've been collecting it in a pond. We've just recently done a rain garden, which I probably won't show you today, but maybe in another session. And we're just trying to re-infiltrate and hold on to as much water as possible. And even with all of that, we still have a lot of water that heads out onto a roadside ditch. All right, let's look at some of the other items. So there's some calculations you're going to have to make, and all of those calculations are on the template file sheet. So you're not going to have to figure those out. You don't have to figure out the formula. That'll all be right in front of you. And it really depends on whether you're using metric or imperial or US units. So that's pretty straightforward. Let's take a quick peek at, let's see, we'll just go through the template file here. Not sure why I can't see it. So again, there's your water survey, drinking water source, wastewater. That's pretty, and there's some examples here, right? So those are always really good to look at. And if you have a well, whatever information you have on that's great. I mean, this has a huge amount of info on it that you may not have. If you have a well, you may also be doing annual testing on it, which is a good idea. So maybe some of that information you want to include. And the next page here, we're looking at your annual average rainfall, type of roofing materials, impacts of major events in your area or on your site. That's pretty easy. And then a SWOT analysis, of course. And then we get to the watershed map, which is, this is where it gets a little tricky. So we have a watershed practice sheet. Now, not only that, if you kind of zoom out a little bit here, you'll see that we have a couple of tutorials, often with the sheets, which I'm sure you have discovered. There are tutorials built into the template, and these are definitely worth taking a look at. Let me zoom back in. So in essence, what we're doing is wherever our project site is, and in this example, it's actually in a pretty wet area. You wouldn't want to build a house here, as you'll probably discover. But this is the project site boundary. And typically what we do is we will, let me just try and make the screen a little bit bigger here. What we'll do when we're figuring out our micro watershed is we'll first start at the lowest point in the project site. So that's down at this boundary here. And I'm just going to start drawing a line here. And then you can see right away, based on this contour information, these are 10-foot contours, that we have elevated lands above this corner here. So what we start to do is realize, first of all, that water is always going to flow at a right angle to a contour. And there's a great there is a great tutorial here I recommend you take a look at. So with that knowledge, you can see why we really need to have contour information. And B, it makes it quite simple to figure out where the water is going to flow, not only on the site, but off site. So if we kind of go in reverse order here, so we know this bottom corner is our low point, as well as over here. And I start drawing a boundary, micro watershed boundary from that point. I know the next contour, that water flowing from this point is going to be right at a right angle. So you kind of have to project where that would be and draw down to it, and the same thing with the next one, and to start matching up your lines. Now, I'm not going to do this whole practice sheet. I would recommend that you do, but you can see on this map that this is a slope that goes uphill, and there is the peak of the slope, and then it starts to go downhill, and then there's a little, not a valley, but a little low point, and then it goes back up. And then we have the same thing going on here. So there's these little peaks throughout this area, and those, as a spoiler alert, those are going to be some of your boundaries. So you know pretty much water that falls here is going to drain downhill and influence the project site. But any water that hits on the other side of this ridge is going to flow in the other direction and away from the project site. So this is a really useful practice sheet to go through. And again, looking at these tutorials should really help. Next, we get into, oops, let me just get rid of that line here. So next, the next page we're looking at is the macro water sheet, or sorry, macro watershed, not macro watershed. And here's an example of that. So the project site's indicated, and then this is a macro watershed that was taken off the web. And again, they're fairly easy to locate. So that's pretty straightforward. And then we get into the micro watershed, and that gets a little trickier because you need contour information, and that may or may not be easy to find, but there's some good examples here. Here's one that's very interesting. So you'll notice that the project boundary and the micro watershed boundary are exactly the same. And this does happen in rare situations where your project site may be at a high point in the area. So you can see this is based on these contours that are numbered. So that's important. If we didn't have a number on these, this could also be a low point. So we know this is a hill or a mound up here, and the slope, the water flows away from it. So again, this is a good friend of ours has a site very much like this. They are at the top of their micro watershed, and they don't have any water come in off of neighboring properties. So very valuable info to know. Let me see if I can get slightly. There we go. There's another example. You'll find this one in the module section under student examples. Here is an acreage site. It's about 2.5 acres, 3 acres, I believe. And there's contour data. Now, this student didn't indicate the elevation. There's no indication of what line represent what elevation. So that's nice to add. So if you had, this is from LiDAR imagery. So it would be very helpful just to put in a couple of elevations. It'd also be helpful to know if they're 1-foot contours or 2-foot contours, or exactly what they are. But the project site boundary is in red, and then you can see that this person started at the low end and they started to travel at right angles to contour going uphill. And then you'll note that they hit a roadway here. So this is something that you really want to keep in mind, especially those in urban areas, or in urban areas, because roads tend to be really drainage catchment areas. So you very rarely would have water, if ever, flowing from one side of the road over onto the other side, maybe in some extreme event. But that normally doesn't happen. So any water that hits the road is not going to go beyond that. Now, there may be an exception in rural areas where you have a roadside ditch, where you may be picking up half of the road. That's quite possible. But in this case, this student has gone up to the road and followed the road up. And then right here is a high point, and they've circled back down to the bottom of their project site boundary. And you can see that they are contained by roadways. And that's, I think, why they stopped here. Yeah, looks like it. So that's an example of acreage, what can happen on some acreage. When we get into larger acreage, it can be much, much different. And this is an excellent example here. This is more of a macro, really. But you can imagine if you're on 100 acres, which I believe a few of you are, the mapping that you need to look at would have to be significantly larger. So let's just take another look here. These aren't quite as self-explanatory. So we're going to go through a little exercise and create our own micro watershed map using Contour Creator, just in case you don't have contour data and you need to find it. Of course, we have a Q&A there. And just to touch on the last part of the assignment, which is, very valuable. There's a lot of points here. We want your site water flow map, which we covered. And again, there's always excellent examples of that here. And here's the site that was on top of, their micro watershed was their site boundary. There's an excellent example of that. And we take some of the data that we've accumulated. So our total area of the site, our average annual rainfall, and then we get the total. So the formulas for both metric and imperial are here, and they're quite easy to follow. A little harder if it's imperial. You have to get the area and multiply it by the total feet in terms of your annual average rainfall, and then also multiply it by 7.48 to get gallons, whereas metric is just the square meters times millimeters to get total liters. Super simple. Then we're going to break that out. Here, we're going to have different impervious surfaces with your roof and then your driveway below. And the same idea, what the material is, the size of it, your average annual rainfall, the maximum 24-hour event, if you're able to find that, and then the runoff coefficient with your materials. And there's a table right here that you can click on to find that info out. I've touched on a few of those as I've been chatting. Here's an example. So this is in metric, and metric is so easy. I love it. This is, so when you get these broad numbers, you just have to pick one and do indicate which you're using. So here are concrete tiles. Honestly, I would not think it's 0.9 for a concrete tile, but that's just my opinion. And it doesn't really matter. You just got to go with a number to get your average collection. So the beauty of average annual rainfall is it's averaged, and we seldom get that. But we do have to know what we're dealing with, and that's how we work that. The last part of the assignment here is your extra credit, and I totally encourage you to do this. It's a little bit of a trick question because it's asking for site water flows that are coming onto your site. Well, of course, that's your micro watershed. Okay, so that's a little bit of a spoiler and some free points there. And then we get your SWOT analysis and any questions you have. So let us take a look at Contour Map Creator. So some of you may not have contour info, and you might want to use this tool to grab some. Now, I would not use this for professional purposes. It's just not that accurate. But for this assignment, and if you don't have any contour data, then this is a good resource. So if you go to Contour Map Creator, you can just Google it and you'll find the site. Let's get our resolution a little bigger. I guess that's as big as we're going to go at the moment. So what we want to do is, let's take a look at We'll just pick a site here. So let's say our project site is right here. Okay. What we want to do is get data for it. So we know that these roads are really drainage points and they're not going to play into our micro watershed boundary, or they would be the boundary. So what we do is we just make 2 clicks on the map. And in this case, I guess I clicked before. So I'm going to want to try and grab this whole block because who knows, right? Maybe all of this drains onto this project site. And then down here, what I prefer to do is dictate the contour increment. So let's say we're at 1, so that would give me 1-foot contours. Okay, and then it's simply a matter of hitting get data, and boom, we've got it. So we have a legend on the right, which obviously doesn't cover everything we're looking at, but blue is the low and red would be the high. So in this case, we are going to just do a fictitious project site boundary, and we'll do it in red. I'll try my best to not sure if those are 2 homes. Okay, say let's go like this. So let's say that's my project site boundary, and I want to figure out what is influencing it. So again, we would go to the lowest portion, and I think I'll make this in pink so we can see it. It may be too thick, but we'll see how that goes. So the low point is over here and here, and you can see these are all right angled. So it looks like yeah, that's too thick. Okay, I'll try that. It looks like my micro watershed boundary would come straight up here. And then it just starts to creep out just ever so much, but not much. And didn't do that quite right. Try again. It's kind of hard with the tool I'm using. Oops. It's not what I wanted to do. Okay, we're going to start at the bottom again. You kind of have to project forward. And again, this is not quite as accurate as it could be. So it'd be kind of like that. And then I would come down the side of the road onto the project boundary itself and around. So for this site here, based on the contour data I have, we could say that this is my micro watershed boundary. Now, if we pick a different site, we're going to have much different results. So, but that gives you a little bit of an idea, how to get the information itself, and then how to roughly calculate where that water's flowing. So again, the water's flowing downhill at right angles to contour, and we always want to start at the low point. Okay, is there any questions at all at this point from anybody? Happy to answer them. You can put it in the chat. You can unmute yourself if you wish. If you want me to do another one, I can do that. Completely up to you. We can even take a look at somebody's site here if they want. So we can do all sorts of things. I've got about 25 minutes left, so we're doing really well with time. Well, what maybe I'll do, I'm just going to start Google Earth, and I'll show you. Yeah, okay, Joe wants another example. I will do that. I'll do it. Uh, let's see. Well, I tell you what, Joe, do you mind if we practice with your project site? And if you're okay with that, do you want to just type your address into the chat here? If you'd prefer not to, that's fine. I can find another location, but here we go. Oops, I'm in draw mode here. Uh-oh. That did not work. Just figure out why. There we go. Now, the one thing I find challenging with this is actually finding the site. It doesn't give me a little marker. Can you, Joe, I'm assuming that it's either one of these houses here. Is that correct? It's supposed to supposedly give us the site in the middle of the, so I'm not sure if it's either one of these. South side of the road. All right. So we're over here. This would be A and this would be B. Is it either one of these? If it's easier, you can always, oh no, you can always, I think you have a, sorry, internet is lagging, no problem. Okay, well, Joe might be having trouble with his chat here. So what we'll do, we'll just, I'd have to go, yeah, no problem. This is the one challenge I have when I'm checking people's, or, yeah, where your house, right over the brown. Okay, there we go. Thank you, Joe. Oh, right. So one of the things you'll find when you're using this, if you do zoom in, it starts to put you into a weird perspective view sometimes. So there's often this little button here to tilt the map back. And that's what we want to do here. So we can see the roads, and those are our constraints. And we have 1 foot contours, so we're still set up. I'm hoping I don't have to refresh the site here, but I might. Yep, it looks like I do. I'm clicking on the screen and it won't. Okay, so I am going to refresh this and we'll go back to, unfortunately. All right. Okay, so we know that the streets here are constrained. So we have the settings where I want them, I think. No, let reset. So I like to start with 1. Now, if you're on a larger site, that's got some undulations to it, you may want to play with that. That may be 2 foot, might be 5 foot. If you have 1 foot contours on a large site, it might just be one big blur and not really show you a lot. So let's designate our boundary here. I would think that that's going to be the boundary of it. So we'll just say get data. And you can see that the low point is here. And there's a high point over here. But if we look at these carefully, let's say a drop of water is here and it hits this contour, and then it's going to flow at a right angle. It's going to hit here, and then it's going to move in this direction. So it's actually, it doesn't look like any water from this top corner is going to affect Joe's project site. So let's put a site boundary around it. We're going to do that in pink, so it's a different color. And it's going to be kind of accurate. Not completely, but kind of. Okay. And then we're going to use a different color for drawing. And we'll start at the low point. So the low point over here is the south side, the bottom, right? Based on our legend on the right. Red being high, blue being low. So if we start at the bottom, and we head on an uphill, it looks like right there, on that side. So that's one side of the boundary. If we go over here and we're going up, so I would say, Joe, that your micro watershed boundary is kind of like that. Now we could increase this here. Uh-oh, I see what I've done wrong. I didn't hit this here. So I'm going to redraw. There we go. We have slightly more definition. And let me scrub that and start over. I'll just leave that line alone. All right. So again, we're starting at the low point, and now, because we have a little better resolution, we can see so that is kind of what I see on this side of the property. So that would be the east side. And then we start on this low point again. We're going up. And we're still on the boundary here. I don't see any. And then it's going to change. And then there's no info here. So we'll just go right back. So that's pretty close to what we had before, but a little different. And again, you can see if you're looking at these high points and water hits here and it's going bang, 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 then it's there, and then it's there, and then it's there, and then it's here. You can follow the path of the water if you're starting at that high point. So you know that this water in the high point will not hit this site. It doesn't travel horizontally. It's going to go at a right angle. So hopefully that helps you out, Joe. That's pretty close. Now, if you were on a really flat urban site, you could even change this and go 0.5, so 6-inch contours. And that'll give you even more resolution. And I would say that would not profoundly change what I've done. It might bring me out here and then over, but that would be still pretty close. And, as we get higher and higher resolution on this particular map, we're going to get less and less accurate. So this is all based on Google Earth mapping, which again is very inaccurate, but it's a good tool for this exercise, and it does give you a general idea. And if you went out to your project site, Joe, and looked, you'd probably say, yeah, that does slope to the bottom. And again, this is really helpful as a starting point. So I'm glad that helped out, Joe. All right. And again, this takes time to to get used to. So don't be compassionate with yourself when you're playing around with this. It takes a little while to be able to look at contours um, in a different way, in a way that kind of shows you where the water's flowing. And again, that's the value of this of having contours for your project site. And that's something that with all our designs, we aim for. I will can actually show you. We got a couple minutes left here. Is any questions regarding what we've done at the moment? Anybody want to review anything? If not, I can just show you a couple of other items here that might be relevant.
Hey, Jamie, I'd love to review whatever you got. I was just wondering, would it be appropriate for me to, at the end, talk a little bit about the work party we've got going this weekend?
Oh, absolutely, Max.
Great. I'll save that till the very end.
I saw your question it's not really a question, but I saw that note on the sheet here. So yeah, if you'd like, go right ahead. It's an exciting opportunity for anybody that's in your area. So yeah, feel
Yeah,
free.
sure. So I know a lot of y'all, a lot of folks in the group are Portland, Southwest Washington, Greater Willamette Valley based. And so my design site is on the Lower Columbia. It's about an hour and a half from Portland. And we've been doing about once a month, we've been having work parties out there, and we're starting to get comfortable hosting people and like really making the most of free labor and starting to open it up a little wider. And so, yeah, this coming weekend we'll be having folks out there. It's kind of a camp out thing. If anybody's free, wants details, please give me a holler.
Yeah, right on. That's great. Thank you for sharing that, Max.
Yeah, thank you.
Yeah, I'm sure that anybody in your area would have some interest in that. Well, let's leave Contour Creator. Just get rid of these lines or they're going to follow us. And I'm just going to stop share and switch over to Google Earth. And this is a tool we use in our work. And we don't really use it for design, but I'll show you what we do use it for. I'll just go to a project site we're working on. So here's farm, small farm holding in area where close by Port Alberni. And what we're able to do is we are able to take LiDAR data in British Columbia, Canada here. We're very lucky. We have a public LiDAR database, and we can grab raw data from there and convert it with a software called QGIS. And with that, we're able to create contours. Well, software creates it for us. And then it's beautiful. It's not very intuitive software. It's very difficult to learn. At least I find it difficult. But the nice thing is we can take the data and we can project it into Google Earth. So we're able to share information with our clients this way and just get a very good feel for the lay of the land. These contours have data attached to them. The elevation data is right there. So they're not labeled, but what it allows us to do is, this is a bigger picture of the area. There's a hillshade projection so we can see where the drainage in the area is and how there's a small bit of drainage coming off of that property. We can take the contours away. That's our project site boundary. And we can see we've got plenty of water flowing through it. And we can see what's going on in the surrounding area. We can also create a slope analysis with QGIS, and that really helps in terms of knowing the slopes on the property, and then what that allows us in terms of usage. So it's kind of it's a really cool thing to get into. We also have our land capabilities here. Let me just see if I can, I'm not sure why that's not working. It's very similar to the slope analysis. It just allows, here I can go to another, there it is. There's another project by the Fraser River. This is the land capability map and the hillshade map. Actually, this is two pieces of LiDAR data stitched together. And this is the Fraser River going through the area. And these clients are right on the edge of it. And you can see huge slope and a huge amount of erosion going on here. This is a rail line going through the property, which really is a challenge, trying to get a water source that's here onto the rest of the property through or underneath a rail line. So it's basically pretty much impossible. But this classification lets us, communicate with our clients what the possibilities are. And once we get into these higher percentage slopes, we know that we're just trying to stabilize it rather than have it as arable, usable property. So that's a little bit on Google Earth. I don't think I have. Let me just see. Here's a little urban project that we are involved with. We're just starting, actually. And I don't know what my slope. Not sure why I lost that. There we are. So I have 1 foot contours here. There's the project boundary. And you can see this is pretty flat. So, we can see that when we're on the project site, but it's nice to have it laid out for us on our design software. So we don't use this for designing, but we do use it for visualization. And we can tell through this how much influence other parts of the neighborhood have on this. So if we go and we click on this line that's at 6553.2, 6522, 6588. So you can see that this is a little bit of a high point versus the neighboring properties. So it's just a useful tool. It's not anything other than that. What we do with our designs is we will, instead of exporting these contours onto Google Earth, we do this first, but what we do is we export those contours into Vectorworks, which is software that we've used for a long time, and it georeferences it. So it will place it onto the design in the correct location, and then we start working at it. And I actually made an additional layer. I could see if I can just drop it in here for 6-inch contours, because I didn't find this was really helping. Let's see if I can find it here. No, I did not export it to Google Earth, so no big deal. Anyhow, thought you would all be potentially interested in that. That's the one thing about, oh, sorry, I've missed some of the chat here. So Joe had a question. Was there a video example of importing LiDAR data to Google? Yeah, well, unfortunately, there's a step in between. So what you have to do is you take the raw LiDAR data, which is an LAS file type, and you have to put that into QGIS, and then you have to basically, yeah, I don't quite have enough time to do it today, but it's something I could show maybe next time, Joe, because when we get to soils, it's traditionally a little faster. It's a slightly easier assignment after this tough one. And maybe during that discussion, I can touch on it. But basically, we take the data, we put it into QGIS, and then because QGIS is giving us really it's a picture that's made up of a bunch of points. So that last Google Earth image I showed you that was just simple contours, there may have been 7 million points on the file to extrapolate that. So we have to take out all the houses and the trees. And then once we do that, we tell the software to fill in the blanks and then to extract contours, whatever contour denomination that we want. So in that case, it was 1 foot. And then once it's done that, then we can push it outside of the QGIS into other software like Google Earth. And so it's a bit of a process, and it's not easy. I'll say that. Luckily, I'm taking and some of you may have already heard me going on about the Rex farm planning online course that's offered by Darren Doherty on the Agrarian platform. And fortunately, he has, amongst other things, one of the offerings for what's called planner members is access to some video courses. One is on QGIS. So when I have to use it, It's a great reference. I can look, it's really well laid out. I can look up exactly what I need to know and see a short video on how to do it. And I use that to get through any tricky parts that I'm unfamiliar with. Um, okay, Gabriel, yeah, good luck with your dog. It's sad to hear it's not doing well. And thank you for being part of today's meeting. Um, but yeah, Joe, I will, I'll try and kind of touch on it next week. You can, it's a free software, QGIS, it's open source, but it is, again, really tricky in terms of learning. And there's lots of resources out there, but I've got a really good one I can reference, and I'm very lucky about that. So most, as you get deeper into software usage, quite often there'll be multiple types of software one uses in land design to get information they want. And the LiDAR is just wonderful resource that we can access. We just have to be able to convert the raw data into some usable information. So, all right. So if anybody have any more questions that they have today, happy to answer them. If not, we will call it a day and wish you all the best with your assignment. And then after your assignment on Monday, next Monday, so a week Monday, uh, after that, we're going to have, I believe it's a couple of week break. And then we come back and then we'll have a Q&A on lesson number 6, which is soils. And, it's a slightly easier exercise. So for those that feel a little bit overloaded with this lesson, not to worry, the next one is a bit easier. And again, if you get into any trouble with this lesson, just drop me a note and we'll do everything we can to point you in the right direction. But hopefully this recording of this meeting will be helpful to reference. So thank you very much, everybody, for being part of the meeting today, and really enjoy these Q&As. And best of luck with your assignments. We look forward to seeing them next week. So have a great week.